Hello and welcome to another edition of Cracking the Cryptic. We had a request to try a puzzle from The Guardian. I think this is a hard sudoku that they published, so very happy to do that. Just to say that we really welcome requests. It's a way of us finding good puzzles, good enjoyable puzzles. Mark and I are both puzzle nuts, so we're always keen to see new puzzles, and we'll always, if we have time, try and accommodate. So without further ado, I don't know anything about how hard Guardian puzzles are normally, but I imagine this probably isn't that straightforward. Anyway, let's go. So okay, I can see 8 here, so that's going to give me a big 8 down at the bottom. Let's put that in. And just a general point, I suppose, this box of 4 numbers here, that's screaming as a place to start for me. I'm always scanning the outside numbers here, you can see, and this 6, 5, because they restrict the remaining cells so significantly. And you can see that has to be a 5, this has to be a 3, without doing really anything at all. Start putting some pencil marks in. There's an 8 there, look. 2 8s here, this has to be an 8. Put some more 8s in up here. And as usual, the early stage of solving these things is very similar for all Sudokus. Okay, so what's the next step? 2 1s here, 2 1s there. See, this 7 is pushing the 7 into one of these 3 cells, but I can't see which, and I can't eliminate it down to 2 cells, so I'm not going to allow myself the luxury of a pencil mark there, but I can use it to make pencil marks in the central 3x3 box. And what have we got down here? We've got 2 4 6 down this side, so that now has to be a 6. Let's put that in. That means that has to be a 2 and that has to be a 4, so that all looks quite helpful. Let's fill in some 4s there. To use the 6s somehow. Ah, there you go. Okay, there's a 6 here. Do anything. Okay, let's go back down here now. 3 7 in these 2 cells means that we have 3 here and 7 here. So let's place 7s in here. And we've got 1 9 into these 2 positions, which allows me to say that we need 4 7 here, which resolves this stuff, so that's got to be a 4 and that has to be a 7, and that resolves this 7 here. Let's do that, and we need to pencil mark the 3s at the bottom there. Okay, so 1 2 4 9. I was looking at this column just because it had a lot of numbers in it. Don't think we can do anything with it actually at the moment, so we're going to have to look harder. 3 5 6. Yeah, there you go. That central, the middle column here. So again, I'm only looking at this because it has 5 numbers in it. And you can see we've got 1 3 5 6 to place, and there's a 3 here and a 3 here and a 3 here. So the only place that we can place a 3 in the central column now is there, and that means I can put a 3 here too. And I'm going to carry on working. That felt like a, again, if you find something like that, you should definitely try and follow it up, because it may be, and in fact here again you can see I need to place 1 5 6 now in the remaining cells in the central column, and look at the 5 6 here, so that's going to allow me to place a 1. It's the first one in any of the top 6 boxes, which is a bit strange. And now I know this has got to be a 5 or a 6, and this has got to be a 5 or a 6. And one thing I would do in this situation, I don't think it's going to help me here, but one thing I would always be mentally doing is I'd be testing very quickly mentally I'll be putting a 6 in this box and seeing, I can see that's going to make that a 6, and I'll be just checking across, you know, is there a 6 here that would allow me to instantly rule out that that option. Similarly doing the same with a 5, but 5's harder to make progress with. So just a tip there in terms of speed solving that sometimes can allow you to make quicker progress than you may otherwise be able to do. So again, so now I've got 2, 4 here and here, which I can't resolve. I've got 6 in this set, in this column, so we're looking here at 2, 5, 6 again. It's not going to resolve itself anytime soon. Another tip, when you're looking at these heavily filled rows and columns and boxes, always try and pick one that has one of the numbers you don't have many of left. So I quite like looking at column 9 here, simply because it already contains a 6, and I doubt I'm going to get many eliminations of 6s from the checking entries. So maybe the fact that I've already got the 6 here will allow me to make quicker progress. I need 1, 5, 7, 9 here. Actually, that's going to, I can pencil mark that already. The 9 can only go in, actually, what am I talking about? That 9, that does resolve itself. That could be a 9, and that could be a 7. And that probably might be helpful. Now we can put 1, 5 into the remaining boxes here. I'm going to come back to this box. I'm just going to try and use this 9 first. So we can see we can place 9s here. And I can place 7s up at the top here. I don't think we can go further than that. So now I'm coming back to this box because I've filled, these 2 cells are basically filled. I don't know the order, but I know they can't take any other numbers. So I know I'm looking at 2, 4, 6 in these cells. I'm just wondering whether that is going to allow me to make one more pencil mark here with the 6s, which allows me to put 6s here. This 6 up here scans upwards, and we can place 6s there and there. Here again, I'm focusing very hard on whether I can, if I can, yes, I can. This 6 here and this 6 here allows me to place 6s in these 2 positions, and it's very nearly helpful. So because I have a 6 in these 2 positions and a 6 in these 2 positions, rows 1 and 2 can take no more 6s. It would be impossible for there to be a 6 here or a 6 here, because that would instantly mean there would be 2 6s in a row or in one of these rows. You can test that for yourself. Imagine this was a 6. That would be a 6, this would have to be a 6, and this would have to be a 6. So that just doesn't work. Now, that means I can place pencil mark 6s in these 2 positions here. Now, sometimes that would be helpful. Unfortunately, here it isn't quite. So we have to carry on thinking. So 1 now allows us to place 1s into these 2 positions. 5. These 5s allow us to place pencil marks into these positions. And again, I'm scanning across. Can I eliminate 5 somehow? Not quite yet. Okay. Pencil mark 7s in there. Pencil mark 3s in here. This 5 allows me to place pencil marks here and here. Quite an interesting amount of pencil marks that are now in the grid. It's quite rare that this method leads to such a densely packed set of pencil marks without the puzzle cracking somewhere. So well done to the setters of this puzzle for keeping its secrets hidden from me. one of the things I'd also notice is that if you get to this sort of stage in a puzzle, and you could spend some minutes trying to find the next step logically. In competition situation, you'd always be guessing at this point, and part of the skill of good guessing is to pick cells to make a guess in, which lead to a lot of other numbers. So you can see that if you guess up here, for example, if you guessed this was a 6, this would give you a 6, a 7 and an 8 immediately. And normally if you get 3 numbers quickly like that, you can quickly force a contradiction. So I'm almost tempted to try and show you how that might work here, but I think because we've been asked to try and solve this logically, I probably shouldn't do that. So let me just stare at this for a minute and see if I can spot anything clever. Okay. This top row is interesting. Yeah. Yes. Yeah. This puzzle is not very conducive, actually, to Snyder notation, because the thing I've noticed here is not going to be brought out by that notation. I was looking at the top row, prompted by thinking about this being 6, 7, 8 in some order. And if we look at the top row, I think I'm right in saying, so we've got to put in 1, 2, 5, 6, 7, 8 here. But you can immediately see that lots of the columns contain lots of those numbers already. So for example, this cell here, I think can only be a 1 and a 2 at the moment, because there's so many of the missing numbers here that that are taken up by these numbers. And similarly, we've got another 5 and an 8 down here, and another 5 and an 8 down here. So if we just go back and concentrate on this top row, where we're looking for the numbers 1, 2, 5, 6, 6, 7 and 8, you can see we've got 7 here, 7 here and a 7 here. We've got 5, 8, 5, 8 and 5, 8. So we've got 5, 7 and 8 completely checked in this position, and this position. Now what does that mean? Well, that means there's only three numbers left that can go into these 3 cells, and they have to be 1, 2 and 6. So 1, 2 and 6 are in some order in this cell, and this cell, which means this can't be a 6. If this is a 6, that's going to break what we've just discovered there. So if this isn't a 6, this has to be a 6. Make sure we don't miss the pencil mark. So that's a 6. That has to be a 4. And we can put in a couple more pencil marks down here and here. Therefore, this is forced to be a 6. This 6. And you can see, I think this is probably going to crack the puzzle, because now this central box is going to be filled. This is now a 6. This is a 5. And this is a 3. This is a 3. This is a 1. 2, 4 to place over here. Like that. This, what's that going to be? A 5. That's a 5. That means this is a 5, this is a 6, this is a 1. Which means this is a 2. And I mean, I'd be very, very surprised if the puzzle isn't now solved. Essentially, I'll just get rid of some of the pencil marks that we. Six is no longer necessary. We've got 2, 4 into these positions. Now, just remembering what we said about this cell here, this could only be a 1 or a 2, I think. So that has to be a 2 now. That means this is a 2, this is a 1, this is an 8. This is an 8. Let's get rid of the 6 up here. That's got to be a 7 now. This has to be a 5. 1, 9. You can see we've got a 1, 9 here and a 1, 9 here. Therefore, this cell here has to be a 2. That's going to chain across all over the place on this side of the grid. So we've got 1, 9 to place here. That has to be a 9. This has to be a 1, 1, 9, 1, 9, 1, 5. And there we go. So hopefully that was clear. That was not easy. Interestingly enough, I think I did do a puzzle on Saturday where I talked about the contrast between Snyder notation, which is what we recommend, and the notation where you basically fill in all of the possibilities for single cells in the grid. Now I think, ironically enough, had you done that on this puzzle, that hidden triple, if you like, that was here, here, and here, would have been a little bit more obvious than it was. This is one of those examples where you might have been better with that other notation, but it's still, as I think I've shown, it's still possible to spot these hidden triples and things like that. You just have to, I suppose you have to get into the practice of thinking about what's missing from a row or a column and whether those things that are missing are appearing in lots of the checking rows or columns that you have to look at. So here the trick was to see I needed 1, 2, 5, 6, 7 and 8, and I could see 3 of the numbers in 3 of the columns that were empty, and that was enough. So good practice, good technique, very good puzzle. Thank you for recommending it. Do more of these, just please keep them coming. Thanks for watching.